Welcome to the deep dive. So we've all seen these incredible leaps in AI, right? Especially, large language models. They can write poetry, generate code. It's amazing.
Absolutely stunning progress.
But then maybe you try to get them to do something really practical, like pull specific info from a messy PDF or analyze a key moment in a video.
Yeah.
And suddenly it feels like this brilliant brain is just, missing its eyes and hands.
That's a great way to put it. That disconnect is real. These models are fantastic in their, let's say, text comfort zone.
Right?
But the real world, it's messy, it's multimodal, it needs perception, action, reasoning across all sorts of environments, not just clean text. They need ways to see and act.
Exactly. And that's precisely what we're diving into today. We're focusing on this really fascinating new development called AgentOrchestra. It's basically a hierarchical multi-agent framework, and it's designed for exactly this general-purpose task solving.
And the name itself, AgentOrchestra, gives you a really good mental picture. Think of like a brilliant symphony conductor. That's your main planning agent. And this conductor is leading a whole team of highly specialized musicians. Those are the sub-agents.
Oh, the different sections of the orchestra.
Exactly. Each one plays its specific part, uses its unique skill, and together they perform this really complex, nuanced piece. That's the core idea.
I like that conductor analogy. It really helps visualize it. So our mission then for this deep dive is to unpack how this whole framework actually works.
Right.
What makes it tick? What makes it effective? And, what kind of incredible real-world problems is it already starting to tackle?
Yeah. There are some impressive examples.
So get ready for maybe some aha moments about how AI is learning to, delegate and coordinate on a whole new level.
And what's really key here is understanding how AgentOrchestra tackles the problems that tripped up earlier attempts at building these generalist AIs.
Okay, so what were those main hurdles?
Well, previous systems, they often had pretty limited generalization. They were, maybe too tailored to very specific tasks or domains.
Right, not flexible enough.
Exactly. And they also frequently lacked good multimodal understanding. They really struggled to perceive or reason across different data types, text, images, audio, video, all that stuff.
Yeah, you can see how that would be a problem for a general assistant. It needs to handle everything, not just a nice clean text file. What else?
Beyond that, a lot of the older architectures, they weren't very scalable or easy to maintain. It was hard to add new skills or adapt them when tasks changed. And crucially, most didn't really have effective ways for agents to collaborate. Proper teamwork, dynamic communication on complex jobs that was often missing.
Okay, so AgentOrchestra is designed to tackle all of that head on. What are its sort of guiding principles? How does it approach these challenges?
It's built around 4 key ideas, really. First, extensibility, making it easy to add new capabilities.
Makes sense.
Second, multimodality, so it can handle all those diverse data types seamlessly. Third is modularity, having flexible, interchangeable parts.
It's like plug-and-play components.
Kind of, yeah. And finally, robust coordination, ensuring efficient teamwork between all the parts.
Okay, so you mentioned earlier this two-tier architecture. Can we zoom in on that core design a bit?
Yeah, absolutely. So at its heart, you've got this top-level planning agent, that's our conductor.
Right.
And it oversees and directs a layer of specialized sub-agents. Those are the musicians in our analogy.
Okay, conductor and musicians. So if those are the layers, what are the actual building blocks? Like, what makes up an individual agent in this system? Let's unpack those components.
Sure. So think of an agent as like an independent digital worker.
Okay.
And like any good worker, it first needs to perceive its task and its surroundings. That's its observation.
So what does that include?
It's everything, really.
Yeah.
The user's requests, any attached files, maybe screenshots, plus the whole history of what it's already done, actions, errors, everything.
Got it.
Then what? Then it uses its model. That's its AI brain, essentially. It's a large language model, an LLM, or maybe a large multimodal model, an LMM. And crucially, there's this flexible abstraction layer. This means it can dynamically switch between different powerful models. Think GPT 4.1, Claude 4 Sonnet, Clan 2.5, depending on what the job needs.
So it's not locked into just one specific AI model. That sounds really useful for keeping it up to date.
Exactly. It ensures long-term extensibility.
So it observes, it thinks, using its model. How does it actually do things? How does it act?
Right, actions. These are done using predefined tools. They access these tools through standard interfaces. And here's a really important bit. Any operation that might have side effects, interacting with external systems or changing things, that gets executed in a secure, isolated sandbox environment. Think like a Linux container or a virtual machine.
Oh, interesting. Why?
Safety. It prevents any unintended changes to the main system. It's a safe place for the agent to try things out.
That isolated sandbox sounds absolutely vital. Okay, so with all this observing, thinking, acting, it feels like it needs a really good way to remember everything.
You nailed it. That's memory. It's the agent's persistent record of its entire history. The tasks, observations, actions, even the errors.
So it can learn.
Precisely. It learns from past steps, it can recover if something goes wrong, and it adapts as things change. The whole system runs in this continuous loop. Perceive, store in memory, interpret and pick an action using the model in memory, execute the action in the sandbox, and then record what happened back into memory.
And that loop just keeps going until the job's done.
That's the idea. Cycle after cycle until the objective is met.
Okay, so those are the individual agents, the musicians doing the work. But who's reading the score? Who's deciding who plays what and when? That's the conductor, right? The planning agent. What's its main job?
The planning agent is really the master strategist. It focuses purely on high-level reasoning. Its job isn't to do the low-level actions itself, but to take that complex user goal and break it down systematically into smaller, manageable subtasks.
So it's truly about delegation then, not trying to be a jack of all trades itself, but figuring out who is the expert for each piece.
Exactly right. It assigns these subtasks to the most suitable specialized subagent based on their skills and, what's happening in the task right now. And crucially, it keeps that big picture view.
The global perspective.
Yeah. It gathers feedback from the subagents, monitors the overall progress, making sure everything's moving towards the main goal.
And this is where you said it gets really interesting. It's not stuck with its initial plan. It can adapt on the fly.
That's a huge part of it. It performs dynamic updates in real time. If it gets intermediate results or hits an unexpected snag, or even if the user changes their mind slightly,
it adjusts.
It adjusts the plan. This closed-loop coordination, as the paper calls it, is really key to making it robust. It's not brittle.
That adaptive planning sounds like a massive step up.
Yeah.
So how does it manage this? Is there a specific tool for it?
Yes, there's a dedicated planning tool that the planning agent uses. It provides structured ways to create plans, update them, manage them as they run.
Okay, so this planning tool isn't just for making the initial plan, but also for tracking everything, like which steps are done, which are in progress, which might be blocked.
Exactly. It tracks execution states like not started, in progress, completed, even blocked.
It sounds almost like an AI project manager.
That's actually a pretty good analogy. It ensures complex tasks get broken down and tracked systematically. It provides that essential oversight for the whole operation.
Okay, now let's talk about the musicians, these specialized subagents. Why is specialization so important here? Why not just have one super agent?
Well, specialization is really critical because real-world tasks are just so incredibly varied. Think about it. Searching for information is very different from analyzing data, which is different, again, from navigating a website.
Totally different skill sets.
Right. So by having this expandable set of specialized subagents, AgentOrchestra can actually cover that huge breadth of tasks. And one interesting detail, each of these subagents also comes equipped with a Python interpreter tool.
Oh, what for?
It lets them generate and execute code. They can use it for deeper analysis or maybe to verify calculations or results.
That ability to generate and run code for verification, that sounds incredibly powerful. Okay, let's meet the core team then. Who are these main subagents? First up, the deep researcher agent.
Okay, this one is your expert info gatherer. It uses a pretty sophisticated tool, the Deep Researcher tool.
What does that do?
It optimizes search queries, it conducts broad searches across multiple engines, think Google, Bing, Baidu. Then it extracts the key insights and generates concise summaries. And importantly, it includes source attribution.
Citations. Crucial for trust.
Absolutely. Think of it like a super efficient research assistant that actually shows its work.
Yeah, providing sources is huge for tackling that whole AI hallucination problem.
Okay.
Next up, the browser use agent.
This agent is all about precise, targeted web interaction. It uses something called the Auto Browser Use tool.
And what kind of browser tasks can it handle?
A whole range. Searching, obviously, navigating pages, filling out forms, extracting specific content from a page. And crucially, it can also control things like PDFs or videos within the browser and manage multiple tabs.
Wow. Okay. So it's like having a really diligent automated assistant who can actually use a web browser like a person.
Pretty much, yeah. It's the system's way to see and interact directly with the web.
That is a massive capability.
Yeah.
Okay. And then the third core one, the Deep Analyzer Agent, the analytical powerhouse.
That's the one. Its Deep Analyzer tool is designed for advanced data analysis and interpretation.
What kind of data?
All sorts. Text, images, audio, video, even compressed files like zip archives. It can work across these different formats, and it can even synthesize results from multiple LLMs to boost accuracy and robustness.
So it's the one that pulls everything together and makes sense of it all.
Exactly. It takes all the information collected or extracted by the other agents and provides the final analysis or insights.
Okay, this whole setup, the conductor, the specialized musicians, the tool, it sounds incredibly impressive on paper. But how does it actually perform, in the real world?
Yeah.
Has it been properly tested?
Oh, absolutely. This isn't just a theoretical concept. AgentOrchestra has been put through its paces, rigorously evaluated on standard benchmarks, things like simple QA for factual questions,
Right.
GAIA, which tests general AI capabilities on real-world type tasks,
Okay.
and also HLE, Humanities Last Exam, which is designed to test expert-level reasoning.
And how do you come?
The results are pretty compelling. It consistently outperforms existing systems, including single large models and other multi-agent approaches.
Okay, let's break that down. On factual accuracy, like with simple QA, what did they find?
It hit 95.3% accuracy on simple QA, which is, it's significantly better than just using a standalone LLM or other agents.
95.3, that's high.
It is. And it's not just about the score. It suggests a fundamental improvement in tackling hallucination. Because of its modular design, using the browser use agent to fetch info and the deep researcher agent to double check it.
It mimics how humans research, cross-referencing.
Exactly. That verification step leads to much more reliable answers. For instance, they tested it on questions like, who received the I.E. Frank Rosenblatt Award in 2010? And it could systematically find and verify the correct answer.
That ability to self-verify, that feels like a really big deal. Okay, what about GAIA? That's the one focused on real-world complexity, right? Can you give us some concrete examples of it tackling really tricky tasks?
Yeah, GAIA is where that hierarchical coordination really gets to show off, especially as the tasks get harder. So take a question like this. How many thousand hours would it take Eliud Kipchoge to run the distance between the Earth and the Moon at its closest approach?
Whoa. Okay, that's definitely not something you can just Google directly. That needs multiple steps, different kinds of info.
For sure. So the planning agent first breaks that down. Then maybe the browser use agent goes out and finds Kipchoge's marathon record, his speed over a known distance.
Okay.
And it also finds the moon's minimum perigee distance, about 356,400 kilometers.
Got it. Two separate pieces of info.
Right. Then the deep analyzer agent takes over, performs the calculation distance divided by speed, convert units, etc., and arrives at the answer, 17,000 hours.
Impressive.
And what's really cool is the system often includes steps to actually verify its own calculations along the way.
That's a remarkably complex chain of reasoning, especially pulling facts from completely different domains. What about handling different types of media, like getting info out of an image?
Yeah, there was another great GAIA example. The task was to extract Python code from an image.
From an image, yeah.
Run that Python code, which then produced a URL pointing to some C++ code online.
Right.
And then without actually compiling or running the C++ code, the system had to infer that the C++ code implemented a quicksort algorithm.
Just by looking at the code.
Apparently so. And based on that inference, it had to figure out the sum of the third and fifth integers in a sorted list. Given an initial array, it correctly calculated the answer as 47.
Wow. That's properly cross-modal reasoning and inference without direct execution. That's pretty sophisticated.
It really highlights the capabilities.
Okay, what about audio? Can it, transcribe something someone said?
Yep. There was a scenario where it needed to transcribe an audio recording. It was a professor listing calculus exam page numbers.
Okay, practical enough.
And what was really neat here was how the planning agent adapted. As soon as the system extracted and sorted the correct page numbers, 132, 133, 134, 197, 245, the planning agent recognized the task was complete and finished early.
Ah, so it didn't just blindly follow a predetermined set of steps. It realized it had achieved the goal.
Exactly. It showed this really efficient adaptive workflow, adjusting the plan based on achieving the objective.
Okay, this next one touches on something critical for AI reliability. What happens if it makes a mistake? Can it catch itself? Can it self-correct? Does that actually happen?
Yes, and this is maybe one of the most compelling examples, again, from a GAIA task involving video analysis.
Okay, I'm listening.
The goal was to find a specific phrase, episode select, in a YouTube video at a particular timestamp, and then count how many times the letter G appeared in that phrase.
All right. Seems straightforward enough, but maybe tricky for an AI.
Well, the browser use agent initially watched the video segment and actually miscounted the ES. It thought there were 6.
An error. So what happened?
Then the deep analyzer agent stepped in. It performed a more detailed, fine-grained analysis of the extracted frame or text, and it corrected the count to the actual number, which was 4.
It corrected itself.
It did. The system identified its own potential error and fixed it through inter-agent collaboration.
Yeah. That feels incredibly significant. An AI system that can introspect, find its own mistakes, and fix them without a human stepping in. That's huge for building trust and reliability, especially for complex tasks.
It really is a critical step towards more autonomous and trustworthy AI.
Okay, and you also mentioned it performed well on humanity's last exam, HLE.
That's right. Its strong performance there further backed up its capabilities, showing its advantage over single-agent systems, especially when tasks needed, expert knowledge and using tools in multiple steps. It sort of validated its general problem-solving chops.
Okay, so clearly AgentOrchestra is pushing boundaries, but no system is perfect. What are some of the tricky parts? Where does it still struggle a bit, even with this fancy orchestral approach?
Well, one thing is efficiency trade-offs. All this complexity, the different agents, the communication between them, it can add latency, it takes time and computational resources.
Right.
So for very simple tasks where maybe one really powerful single model could just nail it instantly.
It might be overkill, like bringing the whole orchestra just to play a simple flute solo.
Exactly. That's a good way to think about it. Sometimes it might be a bit too much machinery for a simple job. So there's a balance to strike there.
Makes sense. You don't always need a sledgehammer to crack a nut.
Precisely. It's about matching the tool to the task. And for AgentOrchestra, that means ongoing work to refine how it decides when to use the full ensemble versus maybe just one expert agent.
Okay.
There's also the reliance on external tools and, the live internet.
Dependencies.
Yeah. Tools can sometimes fail. Web content changes or disappears. Websites have different structures. This introduces potential issues with reliability and robustness in some real-world situations. Things can break that are outside the AI's direct control.
And I imagine with all this power, especially interacting dynamically with outside data and tools, there must be ethical considerations too.
Oh, absolutely. They're paramount. When you're dynamically pulling in third-party tools, scraping live web content, well, it raises important questions.
Like what?
Like preventing the spread of misinformation it might find online, protecting user privacy, especially if it's handling personal data, ensuring the whole system operates within ethical boundaries. These are really critical areas that need constant attention, development, and robust monitoring.
Definitely sounds like a crucial area for ongoing work. So looking ahead then, what's the future vision for AgentOrchestra? Where do they see this going? What are the exciting next steps?
Well, a roadmap sounds pretty ambitious. They want to optimize that efficiency issue we talked about, maybe through smarter adaptive routing so it doesn't always involve unnecessary agent handoffs, making the coordination more lightweight.
Streamlining the process.
Exactly. They also plan to significantly expand the team of musicians, the specialized sub-agents.
Adding more instruments to the orchestra?
You could say that. Adding capabilities like advanced data visualization, maybe agents that can build knowledge bases automatically. And get this, even agents for automated scientific research.
Automated scientific research, what does that even mean?
Things like handling literature reviews, maybe helping draft papers, even generating hypotheses based on existing data.
Wow. That's an extraordinary level of ambition.
It truly is. And alongside all that, there's a continued focus on enhancing transparency, making it clear why the system made certain decisions, improving safety features, and ensuring that ethical accountability is built in through robust monitoring and explainable pathways. Responsible development is key.
So just to kind of wrap things up, AgentOrchestra really seems like a groundbreaking step. This hierarchical multi-agent framework seems to be genuinely pushing the limits of what AI can do in terms of general purpose problem solving. Yeah. It's about integrating specialized roles and coordinating them intelligently, moving beyond just one big brain.
Yeah, it definitely points towards a powerful new direction in how we build capable AI systems.
It makes you think, doesn't it? We often picture AI as this single monolithic superintelligence. But maybe true general AI looks more like this, like a highly specialized, perfectly coordinated team and orchestra.
It's a compelling thought.
And if that's the case, how might that shift in perspective change how you, listening right now, approach complex problems? In your own work, or even just in life, thinking about breaking things down, delegating to specialized teams or skills, definitely something to ponder long after this deep dive ends.